I'm Rochelle Mattern. I'm a customer engineer with the Google Cloud team, and I have the pleasure of supporting one of our media and entertainment customers, Vuclip. Today with me, I have two members of the Vuclip team, Kaushik Kulkarni, who's a technical director at Vuclip, and Chetan Dixit, who's a senior director of analytics and insight at Vuclip. So today we're going to be talking about data warehousing using a serverless approach powered by Google Cloud Platform. So to get us started, we're going to start by introducing some of the challenges that are commonly associated with data warehousing and why the serverless model came into the picture. From there, we're going to move on to talk about Vuclip's journey to serverless data warehousing and talk a little bit about the technology choices that they made along the way, some of the migration process that they put into place, some of the use cases that they were able to implement once they put the system in place, talk about a little bit about their results and benefits, and then finally we're going to close by doing a short demo on starting a data pipeline and moving into the data warehouse. So to get us started, I wanted to introduce some of the challenges that are commonly seen in data warehousing and why serverless came into the picture. So we all hear a lot about big data lately, right? And there's a lot of challenges that come into actually utilizing big data. You know, integrating the data together, managing the data, and then actually using the data. And one of the main components of big data is a data warehouse. And traditionally, that also has its own challenges associated with it. So I'm going to start by introducing 3 of the challenges that are traditionally seen, and those challenges were some of the challenges that Vuclip saw in their original platform. So starting with scaling and performance optimization. Performance can be unpredictable across various loads, and that could be due to limited processing capacity. Furthermore, as you need to provision more and more resources, the lead time involved in that can take some time and lead to delays in the projects you want to actually move forward with. Furthermore, lots of time can be spent on operational tasks, and that's not really where the value add is. So commonly, you might have seen infrastructure failures and a lot of time spent on recovery, and that results in delays and more effort spent on operational tasks, which is not where the value add is. Additionally, you have to plan for licensing and software upgrades, and that can further delay your projects, and also to take resources from the things that could be really adding value to your business, and then you're having to do these upgrades, which is not the value add to the business. And then lastly, data access, retention, and tiering has been a challenge. So, for example, if you need to provision data access across the business, you would have to provision accounts across and give passwords and other such things, and that can be quite a pain. That could lead you to just not giving access to people who could be gaining insights from that data. And that could lead to limited ad hoc querying capabilities across the business. And then lastly, data retention and tiering. That traditionally has had to be a manual process, and that's not an ideal state. So how do we get to something that's more efficient and easier to manage? Well, there's 4 key components that need to be put into place. The first being infrastructure. You need infrastructure that is both elastic and reliable, so that can handle the scaling needs of your business, and without you having to worry about the possible downtime that could lead to those delays and projects not being able to be completed. And then furthermore, you need data engineering technologies that can have modern storage capabilities and also modern processing tools. And then also, you need processes in place, possibly processes that involve CI/CD pipelines to handle the change management that you're going to have to put in place as you go along. And then lastly, you need tools that can actually integrate with your applications and business intelligence tools. So you need to be able to consume the data. So Serverless came into the picture and addresses some of these critical components of data pipelines and data warehousing. Traditionally, there was a lot of operational tasks that went into actually creating a data warehouse. Some of those were provisioning resources, handling deployment and configuration, and there was a small chunk of time that you actually spent doing the actual analytics and getting the insights that you were looking for. And then the serverless model came into the picture, and that totally switched the paradigm. So with serverless, you were able to spend a lot more time actually getting the business value add and doing the analytics and getting the insights that you wanted. And less time was spent on the administration. So with that, I'd like to introduce Chetan, who's going to talk to you guys about some of the technology decisions that Vuclip made along their path, and also to talk a little bit about their migration process. So Chetan, welcome.
Thanks, Rochelle. And welcome, everyone. I would like to take a couple of minutes to introduce Vuclip, what we are and what we do. So Vue is our premium brand. We are a premium video on demand streaming company with a significant presence in Asian countries, specifically in Indonesia, Malaysia, Singapore, Hong Kong. We do have other products which are basically B2B, which we call Vuclip videos, and there are Vuclip games. So these are basically our products which are offered as VAS products, value-added services with different telecoms. So we have, on the Vuclip games, we have 2,000 plus ad-free games, which are developed by 15 plus developers. And primarily, we are a technology-driven media company. So at the heart of it is our technology. So just to give you an idea how significantly we are there on the business, these are some of the partners whom we work across Asia and Indian subcontinent and Middle East and Africa, across all of our video games, Vue and Vuclip games. Now moving on to the Vuclip's journey towards serverless. So where we were. So this was our state of affairs before we started adopting Google Cloud. So all of our applications which were serving our main video applications are on-prem. Now, we had different applications which were tailor-made for different integrations with different telecom partners, for different telecom regions and all that. So all our data pipelines were built on-prem. So basically, we had Kafka for our data ingestion. So that was our data ingestion engine. And then we used to have Talent, which was our premium ETL engine. And then we had a bunch of shell scripts which used to do data transformation, and data was getting loaded to the Greenplum, which was, again, our primary data warehouse, which was on-prem. And then we had a bunch of Tableau servers, basically a couple of Tableau servers from where we served our visualizations. Now, what were our pain points over there? For every new integration or every new business that we entered into, for our insights to be ahead of that, what we needed to do was every time evaluation of existing capacity. How much traffic this new integration is going to bring up. We had to see whether our Kafka cluster is going to serve that up. Then we had to plan for the manual, storage capacity for our Greenplum database. How's our data going to increase? So we had to plan for that as well. And then at the times, we had to reshuffle all of the schedules based on different geographies, because we have to distribute load, which is whether it's on the Greenplum for executing queries or whether it's Talent for running different jobs. So we have to every time juggle here and there for our capacity optimization. So how did we move on to the Google Cloud platform? So basically, the first approach that we took was, finding out how does our data plane look like? How are our patterns of ingestion? So this is where we came up with our data architecture patterns. So basically, identified what are the different components which are crucial for us on the Google Cloud. So if you see the first three components which identify the storage. So different storage, for different types of storage, the components that we identified was cloud storage, BigQuery, and data store. So these primarily served all the persistent storage requirements. The next was PubSub. This is again storage, but this served our need for the transient storage. So basically, we replaced Kafka with the PubSub. Then came the processing. What are the different processing things that we need to use? That is basically our data engineering technologies. So we had data flow, cloud functions, and then app engine that was identified as our processing horsepowers. And then we had compute engine. We used this for orchestration of all our pipelines. So this is how we zeroed on our components, which we are going to use for our different architecture patterns. So if you look at all of these, except for compute engine, all are serverless. So basically, they are offered as mainly as platform as a service. So you don't have to worry about the infrastructure lying behind it. Now let me go into the different architecture patterns that we have. So the first is on the top, we have our simple real-time streaming use case. So all the data which comes in from the outside sources lands on the PubSub. Then data flow streaming through data flow streaming pipeline. It goes to our BigQuery, which is operational store. And then the next use case, which is basically our low volume and low compute processing. So all our data, this in the batch mode, arrives at the Google Cloud Storage. For low volume, it gets processed via the Google Cloud Functions. And then data goes again onto our operational store, which is BigQuery. Now for the high volume and high compute requirements, data which is landing onto the Google Cloud Storage gets processed by the data flow, which is in the batch mode. That processes data and goes on to the BigQuery's operational store. Now, we also have different integrations, which are basically API-based integration with internal systems as well as external systems. So for this, we use App Engine, which is integrated with different APIs, which pull data from different sources, and then puts it onto the BigQuery. And last of our use case, which is basically data that we have. So data coming from external sources, internal systems, and then data massaging with our own data, and then putting that data or publishing that data to the external systems. So that was, again, a use case. So on this, we get that data onto the Google Cloud Storage. Data flow amalgamates that data via operational data store, and then puts it onto the PubSub. From the PubSub, different cloud functions get triggered and sends that data to the respective destinations. So this is our kind of all our library through which we just keep on extending, and all our use case gets classified in all these major buckets. Now that we had sorted out our architecture and how we are going to attack it, so basically that was our stage of what we call as proof of technology. Now, the other problem that we needed to solve was how do we make data available to everyone with access and security. So data consumption was our next strategy. So the way we did was all our data was bucketed into two things. So we had data storage project and data access projects. So the architecture pattern that we saw on that, the operational data store and data warehouse, which was there. So on the left, on the rightmost, so those two are the data storage projects. So no one, only the data gets ingested over there, and access is not enabled from these places. So this is how we bifurcated that. Now the way it was managed was all the data which is there onto the storage project gets accessed via the data access project. The way we do is we create different user groups. So on the different user groups, they have different kinds of privileges. So all the users who have access to certain kinds of data, they will be assigned to certain groups, and that is how they will be able to access that data. Now, the way we created these BigQuery views was they are restricted with timelines and the amount of columns which are exposed. For example, the views would be created with a restriction of 30-day data, 60-day data, 90-day data. For example, the more raw data it is, we limit it to the 30-day, 60-day. And the more aggregated data is, we try to make it available as much as we can. So what this does is it enables us to provide access data securely to all our business users, analysts. What also it also does is basically we can connect all our business intelligence tools to this data access project. So we are never touching our data storage project. The other thing what it does is it doesn't duplicate the data. Our data is still residing on the data storage project, and we still have all the data available via data access project. And on top of it, limiting the amount of data which is there onto the data access project, what it does is it controls the cost onto the BigQuery. So the querying cost gets reduced because the number of business users who are querying that, they may accidentally access all the data. But now you are limiting them. Now who accesses the data and what he accesses and what amount of data he accesses. So you have pretty much controlled that. So now that we had sorted out architecture and data access, the next thing, we were on to our journey towards migration, the actual project to migrating from in-house on-prem to the Google Cloud. The first set, like I talked, was the proof of technology and then actual development. In this, we got our data and then started developing the pieces that we explained earlier. In the first phase, our systems were live on-prem as is, and we started our development and testing, and we tested with all the use cases. And the next important step in the migration was the data migration. Whatever the historical data we had, so that was our longest portion, which took time. So we moved all our historical data onto the GCP, as well as our reporting system still was live with our old on-prem systems. In the next phase, we did the parallel run. So basically, streaming data was going on to both the systems. So we had historical data, and streaming data was now going to both the systems, on-prem as well as GCP. Now, once the data was going on to the GCP, we enabled reporting for a few pilot things from the GCP. So all our reporting for the business was now, for the pilot projects, we exposed them to through the GCP. Once we sorted out issues with the pilots and we were good to go, then we actually moved on to our all of the products onto the GCP. There, we disconnected reporting from the on-prem system. We had streaming data, which was still going to the on-prem. That was just as a backup, still going to the on-prem. And then our streaming data was going on to the GCP. All our reporting was done from the GCP. And then in the final stage, we cut off our on-prem systems. And as this moment, we have everything running onto the GCP. Okay, so we have made our journey reaching till GCP. Everything is there, but it is not stagnant. Every day there will be changes which will keep on coming in. You have to change your pipelines, you have to change your logics and all that. So what is the most important thing then? So you need to have continuous deployment processes and test processes which will take care of things like compute creation, packages, installations, whether it's an SDK upgrade or some library in Java, Python. You need to take care of storage creations, the buckets, folders, management of that. The BigQuery tables, view creation, their updations, anything, pubs up, and data flow pipelines. So all of these things you need to take care of in order to be able to run your systems into the GCP. Once you have migrated, that is not the end of the journey. Actually, your journey begins from there. Now, having said that, let's actually go into few of our use cases in detail to get a gist of it. What are the complex things we are solving? Now, to go into these use cases, I would like to call upon Kaushik.
Thank you, Chetan, and thank you, Google Next team and Rochelle for letting us allowing us to present what we have done so far on GCP. So, what is available, and you have already seen that what is available. Now, what we can do with all of these tools and technology that we have. The first use case came right from our migration from the in-house system to Google Cloud, data marts and dashboards. Everyone has those. We also had some. We had to keep them running when we migrated the data. So initially, we started working with the application logs, plain application logs. The streaming logs were ingested through PubSub by streaming data flow pipelines that you see over there. And then the batch data was first extracted onto GCS and then loaded onto BigQuery. One of the fantastic features that we used, that was flexible schemas. So that basically allowed us to adapt to the upstream logs event model changes in almost real time. Then we used the aggregate data marts to create, basically, we used the SQL, BigQuery SQL, to create the aggregate data marts. These were then used by the dashboards and visualizations. Initially, we started with Tableau on-prem because we were not sure of the overall platform stability. Once it got stabilized, we migrated Tableau to online. Then we had some partner reports and third-party data extracts, which actually were enabled by the aggregate data marts themselves. Then along the line came YouTube data requirements. So we are a media company, as you all know now. So we have our YouTube channels from where we wanted to get our engagement data. So the BigQuery transfer services fitted right in. I mean, with a few clicks, we were able to enable the data flows and start measuring the user engagements. Cost is definitely an important factor that you should not ignore. So all our GCP billing data, that is which all jobs are getting triggered, which all users are using these services, what are the number of bytes they are processing, what is the chargeable cost. Everything is exported now to the BigQuery itself. So you can create dashboards and alerts based on that. The next use case is around user journey management. Now, this actually originated from the need of our product team to tweak the application experience for each user. So this earlier, we had some of the ideas that were identified that we should probably offer these kind of offers to a certain region, or we should change the way the sign-up flow works in certain regions. But then for each of those changes, we needed longer application change cycles. To tackle that, we created this kind of user journey management system. The first one in the system is basically the user master data. So all of the applications actually generate logs. We ingest those. We create the central user view using data flow. And we push those user changes onto PubSub. To create the segments themselves, like user segmentation, and then attaching certain policies, which are how the application should behave at a certain given customization point, we created a user interface that was hosted on Google Kubernetes Engine. The backend APIs for that were provided by Cloud Functions. The backend data store was chosen to be data store. Once the configuration is done from this particular UI, the messages flow through PubSub to data flow again, where in a distributed manner, it decouples, or it basically resolves the segment and their priorities for each user and creates user-level configuration. And that then is pushed again to PubSub, from where it is available to any consumer. So we have various kinds of applications that we run. We have mobile browser, we have application, Android, iOS, and whatnot. And also backend. Some of the functionality is covered, is governed by the backend itself. So all of that can then subscribe to the cross-cloud config delivery system. And what worked here really well for us is the the data flow windowing, basically. I think we have seen some of the windowing in other sessions also. The session level windows, late arrival of data, triggering custom triggering based on certain panes, that really worked well for us in this case. The PubSub subscriptions, where we created basically a push subscription to AWS systems also, from where it is served to the AWS applications, and PubSub handles those push subscriptions with retries, with exponential backups also. So a lot of boilerplate code has really been eliminated for us. The next use case was around event-based optimizations. As you see, there are some attribution-related events that we are ingesting using App Engine. That is actually being fed to the reference data preparation, which is handled in data flow. The persistent data, the reference data for each user is hosted in a data store. And then that is actually used by another data flow process, which handles batch and stream events to prepare or enrich those events. And again, they are queued for dispatch in PubSub. From there, the cloud functions have custom event preparation and dispatch, which is then sent to AppsFlyer and MoEngage. So we are basically trying to reward the ad networks which are providing high quality users, as well as we are trying to engage more with the users if they are showing some kind of behavior. So all of that was actually enabled by this particular application. And advanced analytics, who can forget that? So this is one of the simple use cases that we did, where we wanted to understand how our customer, or what actually they are talking about us across various countries. So we have presence across a lot of countries, and that basically comes with the understanding that there are various languages that are being used in these countries. So how we went about this. We started with taking the customer data, loading onto GCS. We used storage-triggered cloud functions to load this data into BigQuery whenever that came in. And from there, we used translation API to translate all of those various different languages, feedbacks in different languages into English. From there, we use knife-based classification and natural language API for sentiment analysis. And we basically created some sort of NPS, if you will, and again, visualized it in dashboard on Tableau Online. So the use case actually highlights usage of ML algorithms that are out of the box, and they actually come with a very good architecture that you can use without doing a lot of coding. They are very well tested, so you don't really have to worry about the retraining and everything. And you can prototype quickly, right? So you can deliver the business use case while it is still relevant. So in general, what we understand from all of these use cases is that we can focus, using all of these cloud components, we can focus on our architecture and focus on our business use case rather than the boilerplate. We do have to plan for capacity. We do have to watch for cost. Even those are actually provided by the cloud platform. And of course, get help and on the support, as well as on Stackdriver and everywhere. We are talking about how these components and utilities are changing so that we can keep updated with latest features. So what are the results and benefits from all of this? So this is now the latest footprint that we have in Google Cloud. There are around 40 plus streaming pipelines, 50 plus BigQuery data sets, as many GCS buckets, talking about 75 plus terabytes of data. There are 100 billion rows of data in all, talking about 300 to 400 million events every day. And there are 1,000 plus pipelines that are getting spawned and destroyed after the work is done. So we don't really have to worry about any kind of infrastructure management. The benefits are, first of all, reduced redundant infrastructure. We always see that. Earlier, we had in-house data platform. Now, we don't really have to manage anything. And once the use case is served, it just tears down itself. High availability. So earlier, if certain traffic increased, then we would basically see failures in some of the components, which would actually cause availability to hampered. But now that doesn't happen anymore. Faster implementations. Earlier, our implementation time used to span around 3 days. Now it has been reduced by reduced to 30 minutes. Infrastructure management overhead. Around 2 people used to actually continuously do something to keep the in-house infrastructure up. Now they are freed and they can do something better. On-demand scale up and scale down. So around 35 transactions per second to 500 transactions per second is just supported without any change. The app engine and data flow instances just scale up by themselves and then again scale down. On the ML and advanced analytics front, ready-made and battle-tested algorithms. As I said, we just need a very little amount of coding to start them using. And faster value realization. I mean, this is one of the area that I really love about it. So we want to make changes. We want to respond to business quickly rather than getting involved in the same kind of boilerplate code. So all of the Google Cloud Platform has really taken that pain out of the development cycle, and we now can focus solely on the delivery itself. So with that, we'll quickly see a demo of one of the use cases that we have implemented. For that, I'll call upon Chetan, and I'll start my prayer to the demo gods.
Thanks, Kaushik. So far we have been talking so much, right? Now fingers crossed for the demo, but let's see. So what we're going to do is we are going to give you a glimpse of what can be done. Okay. Can you flip back to the presentation? Okay. So just to give you an idea what we're going to demo. So we're going to give you a glimpse of how easy it is to starting a end-to-end pipeline with all components and with all your data ready to ingest into your BigQuery. So we'll pull the code from repository, we'll create few BigQuery data sets and tables, we'll create storage buckets and folders inside that, we'll create pub/sub topics and subscriptions, then we'll launch a streaming data flow pipeline, and we'll also schedule a batch pipeline, which we will invoke manually, and then we'll see the aggregated results. Can we go back to the demo? Okay. So here's exactly what I just showed you on the slide. Before we go there, let's quickly do a quick check. So we don't have anything here. There are no data sets, tables. There are no topics and subscriptions here. There are no pipelines running so far. Let's go here. Let's quickly check. And there are no scheduled jobs here as well. So now I've kicked off the pipeline to deploy everything. So first it will get the code from the Bitbucket. Then it will create BigQuery tables, pub/sub topics and subscriptions, and storage buckets and folders. Meanwhile, let's quickly check. So we have our data set created. We have one table created as well. But you see here, it's only a table, which is a static schema table, which is created. And there's no data in it. Let's go here. Okay. We have got the topic created with the name Next 2018 Demo. And we have a subscription associated with it. Okay, let's go to here. So it is still launching the pipeline. It has created storage. Let's quickly go to storage. So pipeline is also launched. We see here, it's running. Now it's putting a scheduled job over there. It has all finished. Now let's do one thing. There's no point if we can't put the data over there. So right now we don't see any other table. It's just the summary table which is there. So now I'll try to put some data over here. So now we are receiving data. Now the thing to look at it is, now it's not tied to a schema. It will create the tables according to whatever data I'm putting onto it. It is still not yet. So this is the pipeline which is running in. It is yet to get the data. See, this table wasn't there. So this table got created depending on the payload which was there that I was publishing onto the topic. Let's do a preview of this. So this table has streaming buffer. Let me just query it. So this is the data which is getting streamed just now. Now we'll go back here. There's a scheduled job here. Oops. So there was no data here in this. So now we have completed end-to-end. The data is getting pumped in real time, and we have just ran a job which just summarizes data on this one. So this is just public data set, which is NYC taxi trip data available in the BigQuery. It's the same data that we took, and we just completed a simple pipeline which takes data onto the PubSub, streams it, processes it, stores onto the BigQuery, and then summarizes it, and it's ready for consumption here. Can we go back to the presentation? OK, so we have seen the demo. What next? So with serverless, pay as you go, build fast with cutting-edge tools from Google Cloud, on-demand scale up to scale out. Yes, definitely experience serverless with GCP. Thank you very much.